Okay, we're going to do some derivation today of some Suvat equations you can follow through. Now all of these are in your textbook and they derive from, starting from motion graphs, then we just get into some algebra, so the latter few are more to do with algebra. Let's jump straight into it. So in the previous video we looked at graphs that look something like this. Now we're going to take a velocity time graph and we'll draw an object doing this. So it starts at a velocity here and carries on getting a steady increasing velocity there. Now it has a starting velocity, it doesn't start at zero, so we need another term to explain that, and we actually call that u. So that's u. And what we're going to look at here today is we're going to look at seeing how we can use features of this graph to explain things. So we're going to use, come to our first Suvat equation, and we're looking at mostly what the gradient of this graph is. So the gradient of this graph is, as you would expect, a triangle drawn much like that, obviously some straight lines and that. And if you look at what these two different terms are, now this is a time, so this is a time here, and this is, well, how big is this? Well, this is v, because we're going to call this time, this velocity here v, and this is u, this is a velocity u. So this side here will be equal to v minus u. So if we look at what the gradient of this graph would be then in an equation form, well, what is the rate of change of velocity? Well, that is the acceleration. So the rate of change of velocity is the acceleration. So acceleration is equal to v minus u over t, and that's just the gradient calculation there. And if we rearrange this equation, we come to v equals u plus at, which is on your equation sheet, and that's the first of the Suvat equations. I've jumped a little bit of algebra there, but do go back and watch some algebra checks videos just to help you with some of these. So that's Suvat number one. And I'm going to rub out some of this working because I don't need it. Now, the next Suvat equation is based, the next two is based on a bit of geometry more than anything else. And we've got an equation there that incorporates velocity, final velocity, initial velocity, acceleration, time. We haven't got one that involves displacement, so let's use one that involves displacement. Well, a feature of any velocity time graph, as you hopefully will realise from velocity equals displacement over time, that's a GCSE equation. If we rearrange this equation for displacement, what you'll see is that it's velocity times time, and that the feature of this graph that's equal to velocity times time is the area under the graph. I'll say that again, that's the area under the graph. That's definitely one for your notes. So displacement of this graph, displacement of this object is the area under because of v times t. v times t. However, you can't just do v times t because it's not a square, it's not a rectangle or a square. It's a mixture of shapes. Actually, you've got a right angled triangle and a rectangle. So we're going to break this up. I'll get rid of this because we don't need that anymore. So if we look very carefully at this, we can see that we've got this shape right here is u times t, because that's the area under that graph, and that's the displacement for that. Displacement for this, remember that from before we used this as v minus u, we're going to do that the same again, and this is t again, so the area under this graph is s is equal to a half t times v minus u. Now, why have I done a half? Because it's a right angled triangle. Okay, if we want to find the area of a right angled triangle, we do base times height, half it, we get the area of a right angled triangle. Okay, so we've got two equations here that will join together, so let's join them together. So S is going to be equal to ut, so right there, plus this bit right here, a half v, well, a half t, I'm sorry, I put a t in there, a half t times v minus u. Okay, well, there's a lot of terms there. Let's see if we can narrow this down a little bit. And actually, we can come back to using this equation here. I'm going to use a red pen now. So if we rearrange this equation to v minus u is equal to at, hopefully you can see how I've done that, then you should be able to see that v minus u, we can replace these, and we end up with ut plus a half a t squared. Why is it t squared? Because we've brought an a and a t to replace there. We've already got a t there, so t times t is t squared. A and a half was there before. Okay, rewind that, go back through it, make sure you're happy with the algebra that's going on there. So that's our second equation there. I'll write it over here so it's out of the way. Right, okay, next one. Again, we're going to use this graph, but we're going to use it in a slightly different way. Now, if I draw a line down there, and ask you to say, well, what shape is that? You might be like, well, from before, it's a triangle and a rectangle. If we rotate this, it quite effectively looks like a trapezium. Now, on your data sheet, you will be able to find the equation for the area of a trapezium. So that's A, B, and there's the height. What's the equation? The area is A plus B divided by 2 times by the height. Well, let's look very carefully here at what these different terms represent in terms of velocity time. Ripped off my T. So let's just draw them on. So this side is A, and that's equal to u, because that's our velocity there. This side is v, because it's from there to there. It's v. And that's equal to b. And this is our height, which is equal to the time. So we've got all our terms in there, and so what we can do is we can replace the area. Remember, the area of the graph is the displacement, so displacement is equal to A, which is u, plus B, which is v, divided by 2, times by the height, which in this case is t. And voila, that is a third Suvat equation. This Suvat equation is really important because it doesn't have acceleration in it. This is the one that you'll go to in times where you don't have acceleration. Very important that you note that, okay? The equation without acceleration. So if you see a question without acceleration in it, that's the Suvat. That's the one you're looking for. Right, so I'm just going to rub out my graph now, and I did mention they not all come from the graphs. This last one, my favourite one, comes quite simply from the algebra that we look at with one of these equations. So let's just write that. So it's a half v minus u, sorry, plus u. Okay, so we're actually going to start using this equation. I'm going to do this one in green this time so that you can see the difference. So we've got our first, we'll start off with s equals a half v plus u. I'm going to put that in brackets, times by t. Now, what we're going to do is we're going to rearrange this equation again to make t. So t is v minus u over a. So v minus u over a. So what we're going to do is we're going to put that in over here. So half v plus u times v minus u over a. So what we can do with that is we can then move some terms out of the way. So we end up with 2 times by a, because we times both sides by a to get rid of the a, and we've got s. We times it by half. Sorry, we times both sides by 2 to get rid of the half. And that's going to be equal to v plus u times v minus u. So what we do now is we need to do some multiplying out. So we start with this one, so we've got v squared plus times a minus is uv, so minus uv, plus so u times v, so that's plus uv, and then we've got minus u squared, u times u. Okay, so we've done all the terms there, and that's equal to 2as. So we need to then simplify this. Well, hopefully you can see that you can get rid of those. That's a load of rubbish. We don't need those. So minus uv plus uv, well, they just cancel each other out. So we end up with something that looks like this. 2as is equal to v squared minus u squared. And if we then rearrange this equation, we can get v squared equals u squared plus 2a. And that is our final Suvat equation, equation number 4. I'll write that over here, v squared equals u squared plus 2as. Now, if you didn't get any of those, do go back, have a look through, have a look in your book. All of those are explained in there. I've done it on the board there, step by step, showing every bit of the algebra for the most part. If you have any questions, do write them down on your sheet, and we'll address them in class. Thank you.